Okay, everyone, we just recently finished up discussing the water cycle, and I'd like to move on to our next cycle of nature, which that I'd like to discuss, which is the rock cycle. Now, with the rock cycle, there's just a few little bit of terminology I want to make sure you understand, and again, just as before, this should just be a review. You've got igneous, which is volcanic rock. It's made from cooling and crystallization of basically liquid rock, which could be in the form of magma or lava. Sedimentary rock is rock that's made from the deposition, compaction, and cementation of pre-existing rock, or in some cases organic matter can get mixed in as well. Then you've got metamorphic rock. This is where pre-existing rock changes due to heat and pressure from the earth. We've got uplift, that's basically forming mountains. That's when rock is pushed up into the air. Remember we talked about that a little bit with the plate tectonics. And then weathering and erosion is where we actually break down and move pieces of rock, and that's due to weather or maybe even chemical reactions depending on the type of rock that it is. There are videos associated with this. I'm just going to link those as well instead of trying to play them. They just don't seem to have that good of quality of volume when I do play them, so we'll just link them to you. So let's start by talking about igneous rock. Now, the rock cycle can start with any form of rock. It doesn't matter, but generally it'll start with igneous is where you'll talk about it. So let's talk about igneous rock. If you look, we have two main types of igneous rock. One is called extrusive and one is called intrusive. Now remember from our terminology a second ago, igneous rock is basically just rock that forms from liquid rock. So it either comes from magma or lava. Think about volcanoes like we learned about with plate tectonics. Well, those volcanoes form what we call igneous rock. Now, sometimes magma, which is basically hot molten rock under the earth, if it can't make its way to the surface, sometimes it'll find little cracks or pockets in pre-existing rock. It'll flow into there and cool off. We call that intrusive. The easiest way to remember that is think of the fact that it's still in the ground. It's inside the ground. That's intrusive. Now, oftentimes, though, that magma, as it's being forced up, will form a volcano like we learned about with plate tectonics. And when it does that and makes it out, we call it extrusive rock. So when it comes out, it cools off on the surface of the earth. It's extrusive. The easiest way to remember that, think of the prefix X and think about like an exit. Like when you leave a building or something like that, well, this is leaving the ground. If you're in the building, then think about like intrusive or something like that. So that's our main forms of igneous rock, is extrusive or intrusive. And I'm not going to get into too much more detail of it than that. Next, I want to talk about weathering and erosion. This is the process that breaks down rocks and land and carries it to somewhere else. If you notice on the little insert on the right, you'll see that it's showing you how weathering and erosion works. And it's going to go through this whole process of making a sedimentary rock. But for now, let's look at weathering and erosion. So with weathering and erosion, you've got physical weathering that we call, or mechanical weathering. That's things like rain, sleet, snow, hail, plants, things like that. They break down big chunks of rock. If you look to the bottom, you'll see how water can seep into the cracks of rocks. And in the wintertime when it freezes, water, as we've learned in the past in class, water expands when it's cold. So it kind of acts like a jack, so to speak. It literally pushes out on rock when it gets to those cracks and causes them to break. It's part of weathering. And of course, as those pieces of rock fall down and get washed away with rivers, lakes, and streams, that's what we call erosion. So we have something also called chemical weathering. Now here in our little section of the U.S., we have a lot of rock called limestone. Limestone has a lot of calcium in it. Think about baking soda and vinegar. When you mix those two together, you get this big foamy solution. What's happening is that baking soda, which is made out of a lot of calcium, gets mixed with an acid, and it causes the acid causes the calcium to break down. Excuse me, I can't think of what I'm trying to say. And as it does that, the same process happens here with chemical weathering. So our limestone has a lot of calcium in it. When it rains outside, rainwater is slightly acidic. So it actually causes that limestone to dissolve. Think about, again, like I said, the chemical reaction that happens with vinegar and baking soda. And as it does that, it forms little caverns. A lot of our caves that we see here in West Virginia have been formed that way. So from there, we're going to move on to sedimentary rock. Again, back to our diagram. Sedimentary rock forms from weathering and erosion. Remember we said you have weathering that breaks those rocks down. So think about rain, sleet, snow, and hail, water freezing the cracks of rocks, it breaks it. When it does that, weathering is the actual part that's breaking the rock down into smaller pieces. Erosion is when it gets washed or worn away. You know, oftentimes here in West Virginia we have flooding and we'll see big chunks of land and like landslides happening and things like that. That's actually just erosion. That's just weather causing dirt and rock and things like that to move. Well, same thing here. Now with the weathering and erosion, what ends up happening is you'll get rocks that kind of settle to the bottom of like creeks and streams and lakes and ponds and things like that. And I'm sure you're familiar with it if you've ever played in any of those. You know, you see all kinds of rocks lining the bottom. So what ends up happening is these rocks start pressing down, they start to create heat. And the more layers of rocks you get above certain layers of rock, like as the rock layers build up, it creates more heat and pressure on the lower levels. And as it does that, any minerals or anything that might be dissolved in that water, the water starts to kind of bake out of those rocks, get squeezed out, kind of, you know, baked out, so to speak. And as it does that, what happens is any minerals that are left behind kind of act like glue, and they glue those rocks together. So that's where we get the compaction and cementation from. The compaction is when more and more eroded rock lands on top of previous rock that's there, and it just keeps building up more and more and more layers, and the bottom layers literally just get the water squeezed out, and any minerals are left behind act like glue. Next, move on to metamorphic rock. Now, with metamorphic rock, you get similar processes happening as you did with the sedimentary rock, but they're more extreme. So what happens is you get a whole lot of heat and pressure going on. Think about when we were talking about when tectonic plates collide together and they start squeezing and they start to form mountains. Think about here in West Virginia, for example. We have a lot of metamorphic rock here in West Virginia, a lot of it due to the process of our mountains forming. When plates came together and squeezed and pushed that rock in the air to form our mountains, it heated the rock that it's made out of enough to make it kind of like soft. Think about like Play-Doh. And as it squeezed it, it caused the rock to reform and form into what we call metamorphic rock. So it heated it up, and then as it cooled back off, we formed the metamorphic rock we have today. And if you wanted to change, say, from an igneous rock into a sedimentary rock, looking at this diagram, you'd see what you'd have to have is weathering and erosion to form sediments. Then you'd have compaction and cementation where it gets glued back together. If you want to take a sedimentary rock and form it into, say, a metamorphic rock, you would just take it and add a lot of heat and pressure to it and just basically melt that rock and turn it into a metamorphic rock. Now, if you added more and more heat and pressure to it, eventually it would turn liquid, turn back into magma, and then when it cools off, it would form an igneous rock. And by following these arrows, you can see how you would form any of these types of rock. For example, you could take an igneous rock that's already cooled and add a lot of heat and pressure to it, and just enough to make it start to become kind of like soft and malleable, and you could form a metamorphic rock. You could take a metamorphic rock and expose it to weathering and erosion and break it down into sediments, and then it could in turn into a sedimentary rock. So as you see with the rock cycle, this process just happens over and over and over again. The rocks we see here on Earth are not the original rocks that were here. There may be some few pieces that are left, you know, in remote places, but overall all of our rock on the Earth has gone through this process. Remember, the Earth is billions of years old, so this process just happens over and over and over, and it's just the way to recycle things on Earth and to recycle the rock. So again, I'm going to put the links to these videos, and I will let you watch those on your own. Okay,